I think I fit pretty well here at the end of your meeting because you've been spending a lot of time talking about how to promote emotion in wakefulness. But I'm going to let you know about that one part of the day that probably can do more for emotion processing than anything else, and it's that time that we spend offline asleep. That allows us to really process our emotions in full. So whether it be something through the empathy training that you do, or just the emotional experiences that we are challenged with every day, all of that is taken in and processed while we sleep. And there's great opportunity to enhance our emotional processing by utilizing our sleep. So I like to emphasize that this is not my original idea. In fact, the idea that sleep might have something to do with emotion processing, you can find historically. So here's an example from Shakespeare, who said, "Sleep that knits up the raveled sleeve of care, balm of hurt minds, great nature's second course, chief nourisher in life's feast." So he had great insight that sleep might have something to do with emotion processing. But I like to think we put some science behind that. But let's think about the day of some preschool kids. So for us, it's about 2 years, 9 months to 5 years old, and the kids that we study. And you might imagine that the day looks something like this. So 9 o'clock circle time, 10 o'clock art fun, 11 o'clock snack, and then at noon, we're going to have SAT prep, which would be the college entrance exams. And it's funny, but it also comes from the reality of many preschools. So this is a preschool out near Boston, close to us, and I'm emphasizing that these are 4-year-olds, that this is a standard written for. So as part of their day, they're going to sound out sentences. They're going to learn about periods, question marks, and commas. They're going to learn the US presidents. And these are 4-year-olds, right? So you can see how some of these preschools, the tiger mom mentality perhaps promoting that our preschool is going to drive your kids further than something else. And so we cram a lot of things into the day. Here's another example from Belmont, Massachusetts. And you can see we've got Friday between 1:15 and 2:15. They're going to have cooking and nutrition. I wish I had that. Wish I had that like in 11th grade. Tuesday, they'll have drama. And all of this is coming with only 45 minutes of rest time. So I'd like to suggest that perhaps our priorities of putting so much into the preschool day, we might be compromising one of the greatest opportunities to learn, and that is capitalizing on that nap that they could be taking in the class. The reason that we would suggest that sleep perhaps could have some helpful function is from a number of studies that have been conducted in adults. So in adults, for instance, we know that memories are consolidated. So whether it be declarative memories would be like if I read you a story and you were trying to learn something from it. Procedural memories, so trying to learn a sequence on the piano or some sort of motor sequence. Creativity is enhanced by sleep. Optimal decision making. So we know in adults that decision making, that idea that you should sleep on it before you make a decision, is indeed true. We also see in our adults, and the point of what I want to talk about today, is that sleep enhances mood and enhances emotion processing. So if we know that sleep is serving these roles in adults, then it seems important to consider what sleep is doing for emotion processing in kids. So I first want to tell you a little bit of backdrop from adult studies. I'm going to briefly make you into sleep scientists, because then you're going to follow along a little bit better with where I go with this, okay? So pretend you came into my lab and I had you learn some word pairs. So I've got random word pairs like gold, tea, cake, seat. So word pairs you probably don't naturally associate with each other. And then I either let you sleep between the interval of 8 p.m. and 8 a.m., or I have you stay awake between the interval of 8 a.m. and 8 p.m. Okay? So I can look at how your memory changes over an interval with sleep and an interval of wake. And this is what we see. And I am going to show a graph, but don't be afraid of it. It's going to be okay. So what we see is, first of all, we train everybody up to a certain criterion. So not surprisingly, before both wake or sleep, everybody's at about 70, 75%. Okay? So with same baseline. But now if I stay awake after I've learned those things, you can see that my performance has gotten worse 12 hours later, versus if I slept after I learned those things, my performance stays exactly the same. So it seems that sleep is protecting these memories from forgetting. It's not surprising if you stay awake, right? Anything you learned this morning, a good 20% you're going to forget by tonight. That's just all the interference and stuff that goes on during the day. That's what we know. But did you know that if you learned it this evening, you're going to have a protected memory by morning? Even if some of that, obviously you're not sleeping that entire 12 hours. You're probably sleeping 7 hours in there, and yet your memory's protected. We've ruled out some alternative accounts. You could say it's about time of day that I'm testing you. You could say it's about this interference that I just pointed to, that you're learning other things during the day. We've ruled that out, and nonetheless, you'll see that a benefit of sleep remains. Now, the reason that that happens is this. You typically learn about two stages of memory, okay? We all know that one stage of memory is I encode, right? Right now, you are learning what I say, hopefully, right? And later, you'll have this stage of recall. That's when I give you the test afterwards. Anybody know that? There was a test? That is recall. So those are the two stages of memory we're really well aware of, right? But there's a stage in between called consolidation. And consolidation is a stage of memory that's your memories continue to be processed even when you're not working on them. The good news about that is that stage of processing actually is enhanced by sleep, okay? So you can promote your memories by going to sleep. What better way to prepare for the exam than take a nap? So some of you will be like, this is a strange, bizarre, phenomenological thing you just told me, and might want to know more. And I want to tell you more because I actually think the underlying science is pretty cool. So to get at what's going on in the brain that helps sleep promote memories and is going to be important to what I tell you about emotion, this is what you need to know, is if you record the memory area of the brain, it's called the hippocampus, while you sleep, and most of these studies, because you can't really record the human hippocampus very well while they learn, it's usually done in animals. So if I put electrodes into the hippocampus of the rat, and while they learn, and the task they learn is a maze, which is actually technically more complex than what I show, but I'm not an animal researcher, so I like to dumb it down. So a little animal learns a maze, and you can watch the brain cells, the memory cells, encode that. And it has a little neural song that goes along with navigating that maze. The really cool thing is if now that little critter goes to sleep, non-animal researcher, this is the way I think it happens. If the little animal goes to sleep and you're still recording those brain cells, what you'll see is that neural song from while it was awake replays. So you can see the little patterns of cells on the right go in a certain order, and if I look at the firing in those cells while it's sleeping, you see the same exact song being replayed. So let's put it another way. For anybody that I just lost, I'm going to give you another way to think about it. If you wanted to learn all of the words to your favorite scene in a movie, what would you do? You'd put the movie on, and you'd replay that scene over and over again, right? We replay it, and eventually you'll learn it, right? In the old days, I would rewind my VCR, showing how old I am. Whatever version you watch the movies on, you'd replay that scene over and over again, and it's a great way to learn the words to your favorite scene, right? That's exactly the strategy that your brain is using. While you're sleeping, put the movie of today in and replay it over and over again. Great mnemonic device, right? That's pretty cool. The other cool thing is you see these numbers in the bottom right of each of those graphs. The top one, it took 1 second to play that song. The bottom one took 0.2 seconds to play that song. So not only is this movie being replayed while you sleep, it's being replayed in fast forward. Ultra cool. So you are replaying this video that you're basically taking of today and this experience. You're putting in your little memory replayer, you're replaying it in fast forward, and you're replaying it without the interference of all this kind of daytime stuff that's going on. It's a nice isolated way to replay the day and learn it and enhance it. You can also have multiple streams of information being replayed, so it's a really efficient memory processing device. So now you know a little bit about what goes on in the brain during sleep, and I'm going to tie that back into why that has something to do with emotion processing in kids. So sleep changes across the lifespan, and we actually study all ends of the lifespan here, but I'm going to focus on the left and the kids. So what's unique is that while in older adults, sleep is going down and memory is going down, in kids, Sleep is super high, and of course there's a lot of learning experiences. We think those two things are going together. This ends at 5, but those plots just would extend if you went below 5 years old. So it's a lot of sleep time, and it's a lot of rich sleep stages. The stages of sleep are good, deep sleep stages. On top of that, we can say that if you looked at naps, naps are very similar to overnight sleep. So if I looked at what sleep is in what naps are in kids, they contain the same sleep stages as they do in overnight sleep. And so I think the naps are a nice microcosm of overnight sleep. So when I talk a lot about naps in the next few slides, that's partly because it's just a nice opportunity to look at sleep function. It's like miniature overnight sleep. But also, naps clearly have a translational significance to people that are working with kids and parents trying to understand their child's napping. So we had a hypothesis that given that sleep processes emotion in adults, we thought, well, perhaps the same would be true in kids, and that these naps might serve an important benefit for kids to learn information, particularly in a preschool setting. Of course, at that point, before we knew the structure of naps, whether they got good, rich, deep sleep, we thought the alternative hypothesis was maybe you don't really get good, rich, deep sleep in naps, so maybe they don't do anything. So that was the first study that we did in this area, and we just looked at a visuospatial learning test. So this is essentially like the game memory. You learn that there's items in different locations. I hide them and give you just one, and you have to remember where that one was. It's great, really child-friendly, and we also know this is a real hippocampal task that we could give our kids to do. So what we do in a lot of the paradigms and a couple of the emotion paradigms that I'm going to show you is we go into preschool classrooms, and between 10 and 11, we'll have them encode that game that I just showed you. And then 1 week we go in, we nap promote them. So all of the kids enrolled, we encourage to nap during nap time. And then after nap time, we look at how much they remember of that game. But we also go back either the week before or the week after and do the same thing, but we wake promote them. So that's a real fun day for some of us, where we keep the kids awake during nap time. We control a lot of things during these conditions, so they're still resting on cots, lights are dim, and all of that. So, and then we go back the next day also, just to see if anything was recovered with overnight sleep. So again, just to show you in the form of graphs quickly, what you can see is when the kids stay awake during nap time, nobody's going to be surprised that they forgot a lot of that information, right? But if they took a nap during nap time, those memories were protected, so just like we see in adults. So that's pretty cool. The naps are protecting the memories from the morning. Now, I'll emphasize, they were learning that about 10 a.m. They then stayed awake until 1, right? They went about their routines, they had lunch, they were outside, and then they took a nap. And so even though this is showing that it was protected, it's interesting that it's protected in spite of all that other stuff they were doing before the nap. We actually have new data that shows that the naps help recover some of what might have been lost by just simply interference right beforehand. And super important, you go back the next day, and everything looks exactly the same. So it's not like, oh, when they stayed awake during nap time, they can catch up with overnight sleep. That nap close to learning at this young age seems to be really important for giving you that memory foundation so that it is there in the long term. So this is just saying that at this time, we characterize the stages of the sleep. And one thing, though, I want to point out is down here. So REM sleep. REM sleep is what we commonly are like, that's a dream sleep. But in adult literature, REM sleep is supposedly the sleep stage that's important for emotion processing. So we could ask, well, maybe naps aren't going to help with emotion processing because our kids aren't getting any REM sleep anyway. However, that would be in stark contrast to the observation of every preschool teacher and parent out there. Because your vision of a napless child is either giddy or grumpy, and actually most often like wavering rapidly between these two states with every 30 seconds. That's my daughter, so I admit, like I'm speaking from experience. So we started examining this. We wanted to know, does naps help emotion processing? And I don't want to get too hung up on the fact that we're studying naps here. The work that I'm talking about, we've now also seen in overnight sleep, particularly in older kids, where we don't have the nap opportunity to examine it. But in these studies that I'm showing you, I'm focusing in on the nap results. Happy to share later some of the overnight results as well. So in one of the tasks, here's how you can study emotional memory in kids this age. You give them neutral faces, and yes, many people have argued with me as to how neutral those faces look. Don't get hung up on that. And with these neutral faces, we pair a little story that's either mean or nice. So this is my friend Stella. Stella is always nice. Today she brought in cookies and everyone got some. Nice statement. Or this is my friend Peyton. Peyton always is mean. Today he spilled milk all over the table and didn't help clean it up. Mean statement. And so the kids are given these statements and paired with these faces. And then later we can say, give them a familiar face as well as a novel face and ask if they recognize them. And we can also look to see if which emotion made a difference. Now, I'll just say that the which type, mean versus nice, actually wasn't very different, so I'm collapsing that here. And what we see is that immediately after the nap, you can see that the nap, if they remembered more if they had napped than if they stayed awake during nap time. That's the delay minus immediate on the left. But you also see the exact same pattern of the bars if I go back the next day. So this follows very nicely with what I showed you with that visual spatial task, that naps protect memories even if they're emotional. So even without that REM sleep in the naps, we can see that naps are helping us remember the emotional information. Okay, well that's all fine and good, but what does that have to do with actual emotion processing? This is about emotion memories. Here's why I think that's important. So my idea is that by processing your emotional memories, you now have a clean slate to take on new emotional memories, so new emotional information. If I didn't nap, what I think of it as is I've accumulated all of these bad things. You know, Mom made me put my shoes on, which to a kid is very emotional. Somebody took my ball. I didn't get the cookie that I wanted. All of those emotional experiences are accumulating across the morning for these little kids. So think of it as the full desk, right? I've got a stack of papers on my desk. If I sleep, I've now filed away all of those emotional memories. I've unloaded them to elsewhere in the brain. I have a clean slate, so now when somebody steals the ball or offends me in some way, I can handle it, okay? I'm like cool as a cucumber. So that's what we think is happening and why I think processing and remembering the emotional memories is so important. But so we tested this, and here's the way we can test this. I don't want you to get hung up on the paradigm, but basically what you do is you show an emotional face on one side and a neutral face on the other, and then you have to respond to where the star is. The star is either going to hide behind the emotional face or it's going to hide behind the neutral face. If I'm cool as a cucumber, my reaction time should be equal whether it's behind the neutral or the emotional face. I'm not hyper-attending to either of them. Give me a neutral face, give me an emotional face, I can take it. And so my reaction time should be the same no matter where it is. But if I am maybe amped up or have some emotional attention bias, then my reaction time should be faster when it's behind the emotional faces. So that's the idea with this task. And what we see is, so we use a very similar paradigm, but in this case, we just give them the task after either napping or staying awake. And here's what we see. So a bar going up will say they're biased towards the emotional stimuli. A bar going down would say they're biased away from emotional stimuli. Both of those are considered aversive, that they're maladaptive behaviors. You would like to see the cool as a cucumber would be centered around 0, okay? So we now have our expectations. So here's what we see. So for both happy and angry, if I stayed awake during nap time, I have a huge bias towards those emotional pictures. I'm much quicker to respond if the star was hiding behind the emotional faces than behind the neutral faces. That's if I stayed awake during nap time. Now, if instead I gave my kids a nap during nap time, you'll see they're centered around 0. So that's exactly that cool as a cucumber effect. So this is our proof that if the kids nap, they come back less emotionally reactive. They're now cool as a cucumber, give them neutral, give them emotional, they can take it. They're nice and centered around 0. So that gives us some evidence that sleep does do this function. We also considered, because it's a common question, well, does it matter if they're habitual nappers or not? Because we enroll kind of everybody. So we have everything from habitual nappers to non-habitual nappers and everything in between. In fact, quite commonly, you have kids that nap 5 days a week and then not on the weekends. That pack mentality, they usually nap at school and not at home. But what we can do is break this down by nap habituality, and we can see in our habitual nappers, so kids that nap frequently, so these are kids that are napping 5 to 7 days a week, you can see that pattern completely holds up, right? That's exactly what I just showed you on the previous slide, but now broken down for just this group. But now if I look at just the non-habitual nappers, so those kids that, quote, grew out of napping, you can see that that difference is much less. So that's that proof that they need this nap less, okay? So that supports that, yes, they in some ways grow out of napping. Just so you note, that doesn't specifically map to age. It's not that 3-year-olds don't grow out and 5-year-olds do. As a lot of people that I've worked with this age group know, that transition can happen on a broad range of ages within there. And we definitely can rule out age per se, but we do think this has to do with brain maturation. So that those non-habitual nappers have matured their brain storage enough that they can take in more information before there's that interference. They have a bigger desk, so to speak, to allow piles of paper to stack up on before they have to unload their papers with a nap. So that's what it means, I think, to kind of transition out of a nap, and that's something we've been working on with some brain imaging lately. So just to summarize an interim summary, so emotional memories, as I said, are consolidated over a nap, meaning they're solidified with a nap, but that's a good thing. It gives you this clean slate, which then changes your emotional attention biases. And then also that this seems to differ for habitual nappers. Those kids that maybe have less mature brain stores really need this function and need to unload in the middle of the day, versus the kids with more developed brain areas could hold it and use that function with overnight sleep. So I also wanted to point to, this is not only with overnight sleep, but also inhibitory control. Because inhibitory control is really the way that emotion regulation is acted out in a classroom, right? So inhibitory control is important. It's that ability to inhibit a prepotent response. It's important to education because this is what allows a child to withhold a disruptive behavior. The lack of inhibitory control is the presence of those disruptive behaviors. It also allows kids to exhibit their learning. So you may have a prepotent response to something, but then your learning tells you that's actually not the response in this situation. I need to replace it with the accurate response. So also, in order to exhibit and display your learning, you have to have good inhibitory control. So that's why we then looked at this idea of inhibitory control and whether sleep plays a role in inhibitory control. Again, our idea was that with this clean slate idea, you would have a clean slate which would give you more inhibitory control, the better ability to control and regulate your emotions, and that's acted out in this measure of inhibitory control. And it's not uncommon that this is measured with something called the go-no-go task. We make it really fun for the kids where you go if it's any animal other than the chimpanzees. They've escaped, all the animals escaped from the zoo. The chimpanzees are helping you, so press the key if it's any animal other than chimpanzee, but withhold your response if it's the chimpanzee because they're helping us. So that's the kid-friendly version of the go-no-go task. They have to inhibit responses whenever the chimpanzees come up. So this is just showing you the difference between the two. If right before sleep, we measure their inhibitory control, that's that gray bar. It's a shorter bar. That's all you need to know. This is in typically developing kids. And this is with overnight sleep. So in the evening, you measure inhibitory control, and it's somewhat low, and you can see that that bar goes up by morning. So they've increased their inhibitory control. That's something we can also see in younger kids if they nap, that we can improve their inhibitory control by letting them rest and having a nap. And this, for us, since we have some interest in the translational significance, in the US, there's high amounts of ADHD, which is a disorder with a lack of inhibitory control. We are interested in whether sleep is also promoting inhibitory control in that population. So if I do the same thing with these kids with ADHD, what you see is they actually don't get this boost from sleep. There's a small difference, but it's a much smaller difference than we see in our typically developing kids. This suggests that there could be a role of sleep in an inhibitory control disorder like ADHD, and that sleep is not allowing them to recover those levels of inhibitory control like you see in typically developing kids, which is a result that we think is really interesting. And I'll just note that there's actually been theories behind ADHD and that they have increased sleep need, and this would be consistent with that theory. So one other thing to add, and that is that we get a lot of data on these kids. So these kids have ActiWatches, which allow us to track their sleep and wake patterns over 16 days. And those blue bars in the middle are showing their overnight sleep. Those short ones on the left are showing their naps. And we can get this data and actually measure how much they're sleeping over the 16 days that we have these on them. We also have questionnaires, which allows us to ask about things such as food frequency. And this is just to say that we see in our kids that the kids that are eating more fast food, unhealthy foods in general, they sleep overall less across the month than those kids that, than those kids that eat less of the fast foods. You can also see the opposite. So if instead we're looking at fruit and vegetable intake, you can see that the kids that eat healthier, more fruit and vegetables, are the ones that get more sleep across the month than the kids that eat less. And finally, a result that just came out is the role of television. We were surprised to see that a number of kids have televisions in their bedroom. This was just something we were observing through our work in the houses. And so we actually measured it. And we found that about 30% of kids in this age range, which is really surprising, had TVs in their bedroom. And perhaps not surprisingly, the TV in the bedroom resulted in less sleep overall in those kids. And it was quite a significant difference in how much sleep they got. In addition to that, we saw that when they had the TV in the bedroom, they were watching more adult-like programming. And that adult programming is probably overstimulating and keeping them up at night. So just to have a grandiose summary, I think you've been following along. So this is that sleep helps us process emotion. So it enhances emotional memory, reduces those emotional attention biases, improves inhibitory control, which is really helping them act appropriately in the classroom. And that we can see this both with naps and overnight sleep. And age, this seems to show the role of naps for really young kids, but don't forget that role of appropriate amount of overnight sleep for the older kids. Let me finish by showing my great lab and the people that actually collected this data.